Long before the first jet on the deck has its engines running, something is already in the air beside the ship. It went up from the deck under its own power, it turned away from the bow, and it settled into a slow circle a few hundred feet above the water. Nothing has begun yet, it is already working. It is a helicopter, and for the next several hours it will do almost nothing visible. It will not carry cargo, it will not deliver anyone, and it will not go anywhere the ship is not going. It will fly the same loop beside the same ship until the flying stops. That loop is the entire point of it. On this deck, the helicopter is not treated as an aircraft that happens to be present. It is treated as equipment, the same category as a catapult, an arresting wire, or a fire main. Equipment is either up and available, or it is not. And if it is not, the thing it serves does not run. Which is why the first item in a flying day is not a jet at all. Before the catapults are loaded, before the first aircraft is turned over on the bow, that helicopter has to be airborne and established in its position. Until the tower can see it out there, the deck is not cleared to launch anything. The same rule closes the day from the other end. When the last aircraft is down and the deck is already being respotted, the helicopter is still up. It comes back after everything else, and only then does the cycle formally end. It brackets the whole operation, first up and last down, every single time the ship flies. Its position is specific, and it is not over the deck. The helicopter holds off to one side of the ship and behind it, roughly abeam the stern quarter, low, and well clear of the center line. That patch of air has a name and a set of numbers, and the crew flies to those numbers rather than to whatever looks convenient. The reason it stays out of the middle is simple. The air around a carrier during flight operations is not empty space. It is a structured pattern, with aircraft climbing away off the bow, others descending onto the angle, and a stack of them waiting overhead. A helicopter parked in that volume would be an obstacle in a corridor. So the waiting station is placed exactly where the pattern is not. Behind and to the side puts the helicopter clear of the departure path, clear of the approach path, and out from under the aircraft holding above. It is also, and this matters more, close. Everything it might be needed for happens within a mile or two of the stern. That station moves. The ship is making 25 knots or more into the wind for the whole cycle, so a fixed point in the ocean would be useless within minutes. The station is defined relative to the ship, a bearing and a distance from a moving object, and the helicopter spends the entire period flying to keep up with a piece of geometry, which is why it circles rather than hovers. A helicopter holding still burns fuel at close to its worst possible rate, and holding still next to a ship doing 25 knots is not holding still at all. Flying slow circles alongside costs far less, keeps the rotor system happy, and lets the crew see the ship from every angle. It flies low as well, hundreds of feet, not thousands. Low keeps it underneath the departure and recovery paths, and low is where it would have to be anyway if the reason for its existence ever actually arrived. Altitude for this particular aircraft doing this particular job is not an advantage at all. It is delay. Getting airborne is the one part of its day that is unlike everything else up there. Fixed-wing aircraft leave this deck by catapult. They are attached to the ship and thrown off the front of it. The helicopter simply lifts off a spot and flies away sideways. It is the only aircraft aboard that does not need the ship's machinery to go. That independence is exactly why it goes first. At the top of a cycle, the catapults are not yet loaded. The bow is still empty, and the deck crews are only beginning to position aircraft. A helicopter can be off the deck in that window without touching anything anyone else needs. 10 minutes later, that window does not exist. Landing last works on the same logic in reverse. Once the fixed-wing aircraft are down and shut down, the deck belongs to the tractors and the tie-down crews. The helicopter needs one clear spot rather than a whole angled runway, and by that point a single spot is the only thing left. It fits into the gap the schedule leaves it. There are more people aboard it than the flying strictly requires. 2 pilots handle the aircraft. Behind them, in the cabin, sits a crew whose entire job is to look out of an open door at the water beside the ship, hour after hour, while nothing whatsoever happens. Their equipment is stowed, ready, and almost always untouched. They are there because the job cannot be done by an aircraft on its own. If anything needs doing on a short timescale beside a ship moving at speed, it needs hands, eyes, and a hoist. And all 3 have to be already airborne, already looking, and already in position. Assembling that afterwards takes time the situation does not offer. Subscribe. Fuel is the constraint that shapes everything else about the arrangement. The helicopter carries enough for 1 cycle, plus a margin, and not a great deal more. It could be loaded heavier, the tanks allow it, but weight costs performance, and performance is the entire reason it is out there. So it flies light, and it flies often. A cycle on a carrier deck runs roughly an hour and a half, and that is not a coincidence. It is bounded by how long the aircraft can stay up on internal fuel, and the helicopter is sized against the same clock. When the fixed-wing aircraft come back to be refueled, its own numbers are getting low at about the same moment. The awkward part is that the deck does not stop in between. Aircraft recover, get respotted, get fuel and launch again, and the requirement for a helicopter overhead does not pause politely while that happens. Something has to cover the gap, and the answer is not to make one airframe stretch further than it can. It is to have 2. So the handover happens in the air. A second helicopter starts on deck, lifts off, transits out to the station, and takes the position over. Only once the relief is established out there does the first one come back and land. For a few minutes there are 2 of them, which is the only way the count never drops below 1. On deck, the turnaround is deliberately short. On many ships, the aircraft is refueled with its rotors still turning and its crew still strapped in. Hose to the aircraft, engines running, everybody in place. That is not done for effect. It is done because shutting a helicopter down and starting it again costs more time than the schedule has to give. Now the part that sounds wildly out of proportion. If no plane guard helicopter is available, 1 aircraft out of an air wing of dozens, the deck does not launch. Not delayed by a few minutes while somebody makes a case for it, the launch does not happen. 60 aircraft and 5,000 people wait on the status of 1 airframe. That is not sentiment, and it is not caution for its own sake. Flying from a ship puts aircraft over open water at low altitude with no runway to turn back to. And the whole system is built on the assumption that if something does not go to plan, help is already in the air. Remove the assumption, and the arithmetic underneath the operation changes. So it is written down as a condition rather than a preference. Plane guard airborne and on station is a line that has to be satisfied before the first aircraft goes, in exactly the way rigged arresting gear and a manned tower have to be satisfied. Conditions get checked off. They do not get argued about on the day. It sits on the status board in the tower along with everything else. Wires rigged, catapults ready, deck spotted, plane guard on station. The people running the deck can take all of it in at a glance, and the whole board has to be green before the first aircraft moves. 1 amber line stops the sequence at the very top. And then, almost always, nothing happens. The aircraft launch, they climb away, they come back, and they land. The helicopter flies its circles beside the ship for an hour and a half. The crew watches the water go past, and at the end of it they land, take fuel, and go straight back out to do precisely the same thing again. That is the correct outcome, and it is also the strangest thing about the job. The aircraft is bought, crewed, fueled, and flown for hours every day on the chance that a particular few minutes might one day need it. Measured by what it produces almost nothing. Measured by what it permits, it produces the entire flying schedule. Between cycles, it stops being insurance and becomes a truck. With the deck quiet and nothing fixed wing in the air, the same helicopter is the fastest way to move anything at all between ships, steaming a few thousand yards apart. Loads go underneath it on a sling, and people and smaller items ride inside the cabin. A sling load is deeply unglamorous and extremely efficient. A net or a pallet is hooked to a single point under the fuselage. The helicopter lifts straight up, crosses the gap, and sets it down on the other ship's deck. 2 minutes of flying replaces an hour of maneuvering two warships close enough to pass a line between them. That comparison is the real reason it is used. Moving stores by line means both vessels holding a precise course and a precise distance for as long as the transfer lasts, which ties up two ships at once. A helicopter shuttling back and forth ties up nothing. Both methods are used, and only one of them costs everybody their freedom to maneuver. So it carries parts, mail, passengers, supplies, and anything else that is needed on a deck, which is not this one. In a formation of several ships, it becomes the connective tissue between them, the only thing that routinely touches every deck in the group over the course of an ordinary working day at sea. After dark, the whole arrangement runs again, identical in structure and considerably harder in practice. The cycle still opens with a helicopter lifting off before anything else moves. It still holds the same station off the quarter, and it still closes the deck at the end. What changes is that the horizon disappears, and the ship becomes a small cluster of lights. So the aircraft is lit deliberately, and the ship largely is not. The deck runs dark to protect everyone's night vision, and the helicopter carries the lighting that lets the tower and the other aircraft place it in the sky. Its crew flies on instruments and on the shape of the ship's own lights, which is the only reference out there. On deck, it has a spot of its own, usually well aft and out of the way of the landing area. Its rotors fold when it is parked, so it takes up less of a surface where every square foot is already spoken for. When it is not flying, it is simply a large obstruction on the busiest real estate on the ship. It has its own deck crew as well. Chocks and chains go on the moment the wheels touch, because a parked helicopter on a moving deck is a thing that can slide. Fuel, tie-downs, turnaround checks, and the walk back out to the line are handled by the same color-coded teams that service everything else up there. Add it all up across a flying day, and the helicopter keeps the longest hours on the ship. Up before the first launch, down after the last recovery, out again for the next cycle, and working through the quiet stretches in between while the fast jets sit shut down and chained to the deck. It is the aircraft that gets the least rest. It also gets the least attention by a wide margin. The launches are loud, the recoveries are dramatic, and the helicopter orbits quietly off the quarter through all of it, turning up in the corner of the frame. Most of the footage that exists of it is accidental. It is in the background of a photograph of something else entirely. That is what it means for an aircraft to be part of the deck rather than part of the air wing. The catapult does not fly missions either, and neither does the arresting gear. They are conditions for flying, and this particular condition happens to have rotors, a crew of 4, and a fuel state that has to be managed like everything else. And that dark deck is worth stopping on. The same ship, the same aircraft, and the same catapults run the entire cycle again after sunset, with the lights down, the crews working by color and by touch, and everything that is merely difficult in daylight made genuinely hard. How a carrier flies at night is the next one.